Hello. Mr. Sanjay, you're muted. Everyone is muted. Cannot hear anything.
Who did that?
But for you, have you seen me?
What meeting is it?
Electrical force.
Okay, these girls were not there for hearing me. So there's electrical forces, there are magnetic forces. Thank you so much, girls.
Yeah.
Okay, any other more forces?
No. Julian.
What do these girls want to say? And somebody unmuted me, I don't know. Okay, girls, can you hear me?
Mr. Sanjay, we can hear you now.
Okay, let us try to answer the question.
They have directed it to me, but I wanted to listen.
Okay.
Someone is asking that surface station count as a type of force.
Yes, it is.
And nuclear force.
Yes, it is.
Someone had also asked for osmosis.
No.
Osmosis is a force.
Osmosis is not a force.
Okay, so for everyone to say osmosis, I wanted everyone. There are no more hands.
There's one more arm I see up. I don't know whose it is.
Teacher, is applied force a force?
Applied is a word. We cannot say applied force. Okay, a force is applied. A force is made to act on a body. That's what we mean by a force is applied. But we applied, what force has been applied? It could be your weight, it could be whatever. So a weight can be applied on a stool. Is that okay? So the word applied is meaning to act on something. Okay, we are not going to talk about normal force, we talk about a reaction force. Okay, normal force is, that is a force acting at right angles to a certain, the surface on which it is acting. That's when a force is referred to as a normal force. Very good, centripetal force does exist. Okay, that one does exist, air resistance exists as a force. Okay, girls, we have looked at the different, there are very many forces, that's what we must know. But in most cases, their effects are almost identical. They will do one or two of those effects. They will, yes, please. Definition for a force, it will be a push or a pull. It is not a force per se, but that's what it does. No. Spring force, those are elastic forces, not spring forces. Okay, girls, let us try to read through and we shall get an idea of what forces are. Okay. So can somebody read for us that introduction? Madam, select somebody to read the introduction.
Queen Victoria.
Introduction.
Yeah.
Has she gone?
I think she has gone.
Okay.
Excuse me, teacher.
Yes, please.
Now Vega Esther. I'm trying to give people hope. Now Vega Esther.
Who can read for us? Today you are not participating. What is happening?
Excuse me, teacher.
Yes, please.
Introduction.
While we're in the lesson, you put up your hand, then you surprisingly disappear, and then it shows that the meeting has been locked.
Yes.
I had meetings, but I also realized they're very.
Okay.
Sorry about that.
We don't know what is happening because we seem not to be in control of what is happening. But we wanted somebody to read for us the introduction, and they had selected somebody. Queen was selected. Queen, I remember it was Queen. I hope she's now fine.
Yes, the meeting had logged out.
Okay. If you're fine now, you read the introduction. I've lost Queen again.
Introduction. You all have experienced a fault in some way.
You have a nice background. Lena, you waiting?
Introduction. You all have experienced.
I don't know. I don't know what is happening today.
So we are on and off, and when you try to join, they say that the meeting has been locked. You can
Yes,
be.
each time you speak, you get out of the lesson, and they tell you the meeting has been locked.
Or if you raise up your hand, they log you out of the meeting.
Okay, just read without raising the hand. Whoever doesn't have a raised background. Just read.
You have been, all of you.
So can I read?
Read.
If one person starts reading, the others keep quiet, okay, and listen. So read. We are not going to go through the protocols because they seem to be disturbing us. So the first person to read it, please, the others keep quiet. So read.
Introduction.
You all have been experienced. You have all experienced.
I have no idea.
Introduction. You all have experienced a force in some way.
You all have experienced a force in some way. Forces.
Mr. Oluka, are you around?
You all have experienced a force in some way. Forces play a role in everything.
Okay, girls, when I read, do you hear or you don't get an interruption? It seems I'm the one who is going to read now. For me, am I okay? You can hear me.
We hear you. Yes.
So the others who have attempted to take us through the readings have all gone off at some point. They just read one statement and then they go. We are not in charge of that, so let us try to read. Okay, I'm reading for you. You all have experienced a force in some way. Forces play a role in everything that we do. It may be kicking a ball, turning a tap, or even taking a bite. What shows that there is a force? In this chapter, you will learn different kinds of forces and how they affect objects. Is that okay?
Yes.
Is that okay, girls?
Yes.
Okay.
Yes.
You all have experienced forces. Right now, I believe people are seated on their stools. I believe. Is that okay? And if you're well seated, in most cases, one of the things, do you know that we get tired of sitting?
Yes, teacher.
Yes, teacher.
Okay. And usually what happens to our bottoms when we are tired of sitting?
They had.
They
Is that
tend.
okay? In most cases, I've discovered that we massage them even, isn't it? Those are reaction forces. A stool, for you to sit on a stool, it must be able to support you. And therefore, as you exert your weight on the stool or your chair, the chair must exert an equal and opposite force. That's the force that we call a reaction force. Is that okay?
Yes.
Okay, so let us look at the meaning and measurement of forces. I was just giving an idea of somebody who thinks that she has never experienced a force, because right now, with the something that is supporting you is exerting a force on you. I hope you get the meaning that we have all experienced forces in some way. Okay, meaning and measurement of forces. Are we together?
Yes.
We look at the picture. Can you identify what is being done in each case? What does it involve? Let us look at the cows in the beginning. What is being done there?
They are pulling the flower.
Pulling.
They are pulling the car.
They are pulling the cart. Is that okay? They are pulling the cart. And I think you remember that the force is a pull or a push. Is that okay? Okay. Now what is happening to the axe?
A push.
Can you give
It's
me
being
what is
pushed
happening?
into wood.
It is being, but did it do that on its own?
No.
What happened, do you think?
Someone probably put it.
Somebody.
I think a force.
You think? These guys communicate and then they stop. Whoever is trying to communicate.
No, teacher, when we talk, we are sent to the waiting room.
Whenever we talk, the meeting gets locked and then we are sent to the.
Now you has been telling me that I think you are not being sent to the waiting room. Can you tell me what has happened to the axe? Oh, so there must have been.
Teacher, may I think a force has been exerted on the axe maybe by someone?
She has also disappeared. Okay, so
maybe someone was using it to split the wood and left it there.
Exactly. So forces, for example, when you use axes, we can use those forces to split wood. Is that okay?
Yes.
Okay, those are the uses of the forces that we see. Can we make any other additions? Where do we use forces? Apart from the ones that have been illustrated in diagrams, where else do we use forces, please?
When dragging a heavy pencil from one place to another.
Dragging a
when
heavy
sharpening knives.
Sharpening knives.
When writing in
when
a
playing
book.
football.
Playing football.
When sharpening a pencil.
When what?
When writing in a book.
Writing in a book.
Drumming drums.
Drumming drums, okay.
When you're walking.
Walking.
Running.
Running. And so on. Is that okay? So they've given us a definition, a simple definition there. A force may be a push or a pull. Can you identify the forces in the pictures shown there? I think we have identified there's a pulling force, there is a push there, I think. A force is measured. Okay, now I think I'm going to give you, at least let me see whether we have a proper definition of a force here. Types of forces, contact forces. Contact forces. Weight, force of gravity. Okay. At this juncture, I think let us capture the definition of a force. We have said a force may be a push or a pull. Is that okay?
Yeah.
Yes.
Now let us add something that somebody already said. A force is a push or a pull. I think you have heard that. Is that okay?
Yes.
That changes a body's state of rest. I'm giving you the full definition that is expected. So you should be writing, a force is a push or a pull that changes a body's state of rest or uniform motion in a straight line. A force is a push or a pull that changes a body's state of rest or uniform motion in a straight line. So that is our full definition for a force at at secondary school. Is that okay?
Kindly, could you repeat, please?
Okay, let me write it down. I'm going to put it down. Look at the video. You tap my window. A force is, okay. Wait. Let me write even bigger words. So that is the adjustment of our definition for a force. It is a push or a pull that changes a body's state of rest or uniform motion in a straight line. So that's what we have as our full definition of a force, okay?
Yes.
And what is the instrument that is used to measure a force?
Spring balance.
That instrument, that the instruments used to measure a force?
Spring balance.
Spring balance.
It's a spring balance. Is that okay? So we measure forces using a spring balance. I hope you remember what a spring balance looks like. Yeah?
Yes. Yes.
They have also given you the SI unit of a force.
Newton.
What is it?
Newton.
Newton. And what's the symbol for a Newton?
Capital N.
It is capital N. Is that okay? Now, please remember that when you're writing that unit for a force, don't write it using a capital N, starting with a capital N. It should be small n, N-E-W, because if you name it like using a capital N, the assumption is that you are naming somebody because they are people called Newtons. After all, this unit was derived from a person's name, a British scientist, Newton. Is that okay? But the unit must be using small letters. However, the symbol is a capital N because it is a symbol derived from a person's name. Is that okay?
Yes.
Okay, so
Yes. I can't see the board.
you cannot see the board.
So I also can't see it.
Okay. Is that okay?
Yes.
So please, those small things must be, yes, please. Okay. So I hope that has been captured. And I believe that we can try to go through. We can continue with our notes. I hope you are together. So they have given you a diagram of a spring balance there. In most cases, you're going to discover that whatever has been suspended, the reading will be taken using this spring balance, using a certain scale. And most of these scales are labeled in newtons. So this instrument is called a spring balance. I think we can show them a spring balance. Let me show you a spring balance quickly. Okay, and a few masses, and we shall see how those spring balances work. Is that okay, girls?
Yes.
Why do we keep on getting off?
It seems that when you speak, they consider it as a form of indiscipline, and they send you to the waiting room immediately. So I think that is not an adjustment done by us. It is something that whoever is speaking is considered to be a noisemaker. That is a new innovation, I think, for the class. So I think that's why we are facing it. Has now become a challenge. Okay?
Teacher Bruno unlocked the meeting.
No, I think we are going to be admitted again. Let me admit, today we're having those challenges. Where do I admit from when? There are very many participants who have been sent out.
I also need to be made a co-host because I keep on admitting them, but I'm not a co-host.
Yes, Mr. Sally, I've made you a co-host. I was trying to talk to you on the chat, but you're not responding.
Okay. Mr. Uruka, we are experiencing that whenever girls try to make comments, they are sent to the waiting room. I don't know whoever has been trying to say something.
No. Yes, one of the co-hosts decided to block the meeting. Okay, someone clicked on the shield and altered the meeting settings. That's why the meeting was blocked. So when I came back, one of the girls notified me and I unlocked the meeting.
So I hope you can assist us because she's not.
No, I'm attending another meeting. Okay,
you
on
cannot
my
assist
phone.
us that now. Mr. Uruka, you can do that very quickly instead of us of talking.
I already unlocked the meeting about 10 minutes ago. So the girls are.
Thank you so much. Thank you so much. Okay, girls. Look at what I have. Look at my window, and I show you what a spring balance looks like. This is a spring balance. I hope you can see it clearly. Are we okay?
Yes.
Okay. So these are some of the weights that we use in our laboratory. You see this stone here. Can you see the value? Oh, it is upside down. A light here. Can you see what it reads?
100 GM.
100 grams.
100 grams.
That is 100 grams. Now look at this spring balance properly. Can you tell me the units that are labeled on that spring balance?
Grams and newtons.
Grams and newtons. Is that okay?
Yes.
Thank you very much. So I'm going to try to adjust this reading. Correct it a bit slightly. So okay. Can you see the pointer of that spring balance at 0?
Yes.
Now let me try to put there. I'm hanging something. So I hope clearly you have seen what I have suspended from the meter, the balance. It is a little bit lengthy, but I hope you can see what I have hung there. Is it okay?
Yes, teacher.
I've hung 100 gram mass from it. Now, can somebody tell me the reading on the spring balance? How will I capture it? I don't know whether I'll capture it because I'm supposed to be suspending. Let me put this a little bit further. I hope you can see it properly. That's what I'm doing from the spring balance. Now, can somebody tell me what the reading is? Can we capture that reading? I don't know. It's too far. I need something shorter. I'll take it ventilator closer. It interferes with my laptop. The thing is too low. Oh, no, I think I can do this. Okay.
Let me also bring the laptop.
So can somebody read?
Sure, could you bring it closer?
It's interfering with my, I think I need another suspending whatever. Hey, I've disappeared. What has happened? Yes, yeah. No, I'm wondering who has removed the video because I did not touch it. We need a thread. I think we need a thread. We need a thread. It is better. Okay, girls, let us get that out of the way. We shall try to do a better job next time. But that is essentially what a spring balance does. Okay, we suspend our mass and we take our readings. We shall get that better. Let us organize ourselves because it is almost time. But we measure our forces using a spring balance, and forces are measured in newtons. Is that okay? Any question? Okay. Let us move on, but for a few minutes, we are only capturing this point that in diagrams, forces are represented by straight lines with arrows. I think you see that straight line and an arrow. Most of the diagrams that we come across all our notes, whenever we are representing a force, we simply draw a line, and at the end of the line, we must put an arrow. The arrow always indicates the direction in which the force is acting, okay? So the direction where the arrow points indicates the direction of the force, and the length of the straight line indicates the size or the magnitude of the force. That is when you measure that line there. It is supposed to be in scale to give you the magnitude of the force. When I talk about magnitude, I can say like 1 Newton. The value 1 is indicating the size or the magnitude. Is that okay? So I could indicate 1 Newton to be represented by 1 centimeter. Is that okay?
Yes.
So forces can be represented by straight lines. Girls, we are stopping there because we are 5 minutes out of the time. So I hope you have captured the different.
Excuse me, teacher.
Yes, please. I'm listening.
Sure, is it standard that 1 centimeter represents
No,
1
no.
Newton?
In actual sense, let me tell you girls, it is only when we are required to draw those diagrams on scale. That's when we use a scale diagram. But under normal circumstances, we simply draw a line to indicate the force and the direction, and then we put the value below this arrow to indicate the magnitude of the force. So we usually write there a value to indicate, we can say 5 newtons. Instead of using that length, we shall say simply 5 newtons. We shall give you the magnitude of that force. Is that okay?
Yes, excuse me, teacher.
Yes, please.
I was asking whether the timetable for the tests is out yet.
Oh, I think it is your teacher who has not posted the timetable. The timetables are out.
It is out.
The class teachers are supposed to post those. It is not my duty but the class teacher's duty to post that timetable to the class group. Is that okay?
Yes.
Okay, you receive that timetable. Those who want to end the lesson, may God bless you abundantly.
Thank you, teacher.
Stay safe.
Thank you very much, teacher, for teaching.